Hello and welcome to this Flexo Tech webinar held in partnership with Miraclon. My name is Michal. I'm the editor of Flexo Tech magazine and I'll be the host today. Today we're looking at the subject of unwanted ink spread. Specifically, we'll be looking at the problems that unwanted ink spread can cause during the press run, and importantly, how this issue can be stopped, allowing printers to run a productive and profitable print operation. Joining us today to explain this phenomenon is Dr. John Anderson, Director of Advanced Print Applications at Miraclon, a position he's held since 2019. With more than 20 years' experience in the flexographic printing industry, John is responsible for driving the development of solutions for existing and future products. But before we hear from John, I need to tell you that there will be time for your Q&A session after the presentation. So if you just noticed at the bottom of your screens below the video panel, you'll see a question box and you can send them through to me. So now, without any further ado, I can hand you over to Dr. John Anderson. John, over to you.
Thank you, Michal. It's a real pleasure to be here. And thank you for setting this up and going through this. Today, I'm going to talk about something that's been around in Flexo since the original start. Unwanted ink spread. It's a relatively new term, but it's something we've had from the first Flexo plate going forward. So we're looking to move that and show you how we can move that forward. So Miraclon has been involved in innovation since its initiation in Flexo. In 2008, we started with flat top and pixel for pixel structures, which were unique to the industry. In 2010, we added the digicap patterns, so the standard digicap, attempting to improve the ink laydown, improve the density that you achieve with Flexo. 2016, we added in the NX Advantage, which allowed us to have a wider variety of patterns that work with different ink solutions and analoxes. So we can work with spot colors, process, or whites, or other colors, or other applications. In 2018, we added the Ultra solution, which is a sustainable plate system that's still being introduced and rolled out and growing around the world. And now we're going to introduce Pureflexo. Pureflexo is an innovation that takes all of our learnings from the previous years and the previous technologies and builds them to a new level. So moving to Pureflexo, what is it? We're trying to provide with Pureflexo a wider operating window. We're trying to take you through surface texturing of the plate, a way of improving the latitude, improving the ink control on press, allowing the printer more options as they go through. It's a patented technology. It's designed specifically for wide web flexible packaging and solvent-based inks. This is the worst case scenario for unwanted ink spread because you have a very liquid ink, very high pressures, high speeds, and a non-porous substrate. So you push the ink around on the surface and cause the greater level. So this is really one of the greater challenges in Flexo, trying to stop unwanted ink spread in this case. How is this going to help the printer? Well, the flexible packaging printer today is always in a challenge. The brand owner's expectations are going higher as we've improved in the last 20 years from a basic cheap and cheerful process to a premium print process. The graphics are getting more challenging. The resolutions get higher. There's lower tolerance for defects. So actually, as we've improved, the brand owner's expectations have improved or gone higher, and that causes us a challenge. To do that, often we need to slow down the press. We need to stop more frequently to clean plates. We have less wiggle room on press, less latitude. So what we're trying to do to give the printer more efficiency and profitability is to improve the latitude, pushing the quality envelope while not driving economic disadvantages to the printer. So that's really why we're looking at this process. And we're addressing, as we do this, a key underlying issue in Flexo. From the very first Flexo plate, which was a rubber material cut by hand, that raised surface, when it was squashed, the ink was pushed off the surface. That's really what we're talking about. And the underlying issue in Flexo. Every Flexo plate, you have that issue that any excess ink gets pushed off the surface. So we're addressing this in a very different way. We're the first ones to try and control this, to understand this, and it's really critical to how we can improve Flexo and take it to the next level. It's characteristic in Flexo. It's something that causes unwanted ink changes and unwanted dirty print. It'll cause color shifts as the inks build up. So this will cause you issues on press that will make you stop the press, will lose your efficiency. So we're really trying to resist this and make a wider operating window for the printer, make it easier for the printer to run the press faster, but more stable. So how do you spot unwanted ink spread? It's pretty simple. When you look at on the right here, we have two images, the digital file on the top and the printed dot on the bottom. It's pretty easy to see that the dots on the bottom are bigger, the printed dots are bigger than the originals. So you have dot gain, you're making the ink grow outside the original digital file. The outer edges of this are darker. That's because most of the ink has been pushed off the surface and it builds up around the outer edge. The other thing you see is the dots are starting to join up. The area between the dots builds and it will join, so you have dot bridging. This will cause color changes, color shifts, and cause you to want to go and change or clean the plates, clean the press. Here you see our 50% is printing 86. 86 is really quite high. As an industry, we're really aiming at about 70 to 72. So what is our goal in doing this and addressing unwanted ink spread? Really, we're trying to print as perfect as possible, but you'll never achieve perfect. So you're going to make it as close to the original digital file as possible. That's a realistic aim, to make us achieve closer to the digital, closer to the original intent, and give you a much more controlled and stable process. So we're not just talking about the effect on print either. Print performance is really important. You have the unscheduled stops to clean plates. You have slower average press speeds. You're going to impact labor. The sensitivity of operator skill. One operator likes more pressure than the other. That will cause different levels of unwanted ink spread. In color management, it's really important because if someone is changing things on press or adjusting on press and making differences, it's going to make it harder for you to control and harder for you to match your proof. So the color management is not as accurate as you'd want it to be. Customer satisfaction tends to go down. What you get on the shelf is different to what they expect. Maybe it's darker, maybe it's filled in, maybe it's dirty looking, so that the shelf impact, the packaging looks poor. Then the product inside is perceived as poor, even if it's perfect. So we want to make the packaging as perfect as possible. And all of these things together tend to reduce factory efficiencies. So you're trying to make the factory run efficiently, run well, give you the results you're looking for. A simple example of how we can change this is, what if you have one press stop a day on one press that takes 10 minutes? What if you could eliminate that? It comes down to a very simple thing. It could be dirty print. It could be having to stop to clean the plates. So if you stop the press to clean for 10 minutes, one press per day, that's over €55,000 per year that you're giving up in profitability. You're losing productivity on a typical CI Flexo press, but you're also giving up another 108,000 a year in potential revenue. So that simple action doesn't seem very important. 10 minutes a day on one press can turn into over 150,000, 160,000 in lost income and revenue. So that's really a big number for you. And if you have 5 or 6 presses, you can soon get into millions of euros. So I'm going to move now from the reasons why we're trying to do this to technically explaining how to do this. We're going to have a look at what happens when we compress the plate. One of the key differences for Pureflexo is this works when we're compressing the plate. And as you all know, compression is part of the printing process. So if I take a simple Flexo press here, it's just a simple schematic. I'm going to look at the magenta unit in more detail. When I look at the magenta unit, there are 2 points that we have compression. We have them when we're inking the plate, when the analogs comes in contact with the plate, you're compressing it as you're transferring it. Think about if you have ink on one hand and you put the two hands together, you don't have one clean hand, you have two dirty hands. So you have the ink transferring from one to the other. That's a really easy way to think about what we're trying to do. And when you come to the plate to the substrate, you're transferring the ink off the substrate back to the final print. So we're in those two compression zones are really when all the action happens. If I take that plate and lay it flat, and it's a typical wide web plate is 0.5 meter in length. If we're running 300 meters a minute, then that compression happens 10 times every second. So that gives you 20 compressions per second. We're talking about thousands and hundreds of a second each compression. So you're looking at a very quick time when the plate is compressed, it transfers ink, and then it becomes uncompressed. So we're really trying to understand what happens in that time. The rest of the time the plate is spinning, it doesn't really transfer a lot of ink. It doesn't move the ink around. It's only when it's under compression. So let me try and explain the steps of compression here. So we have a plate. So what I'm showing here is a dot, basically, or a small area. You have a digicap or a surface texture pattern in the surface of the plate, and it's coming into contact with a CI drum and the substrate on top of it. As we move through the process, we start with it's uncompressed, it's about to start compression. Then we go into some compression. So you see the front edge is compressing, it's getting squashed, it's getting smaller, and the back end is still the same. Any excess ink that's held in that pattern is being pushed backwards, it's pushed back in the plate, in the pattern. Once we get to full printing, we have compression along the whole length. The ink is being transferred, but any excess ink is also being pushed out of the pattern. That gives you an ink buildup, that gives you that dot gain that we saw earlier. And you start to decompress. So the front edge of the plate has stopped printing, it's transferred the ink. The back end, this excess ink is still being pushed towards the back. And then finally, you've come out of compression. So now you've printed and you're moving on. That whole cycle is a 100th of a second, 200ths of a second, depending on the press speed. It's a really, really short time. So it's a lot of things happening in a very complicated ecosystem in a very short time. So how do we try and control this? How do we try and change this? We're going to use microsurface engineering to control the ink, control the airflow, as well as giving you a better ink laydown. So if I take a simple example here, we're imaging when we do the NX system on a green film called TIL. Here we image the areas that we want to print, the higher raised areas and the non-raised areas. So what we end up with, we image in 2 dimensions, the structure, and on the right you see the 3-dimensional structure that we end up with because of the exposure of UV light and plate making. That whole area that you see, the brown circle, is about the same size as a normal human hair. So we're looking at very micro structures, very small structures, trying to control the ink and give you a result. This is what we did in 2010. This would be a standard digicap or A00, and it's built to improve the ink laydown. So the other side is, why do we use multiple functions versus single? When we first started, we had the single functionality in the pattern. So we have a single pattern over the whole surface, like the one you've just seen. This allowed us to break up the pattern from the analog scroll. What you typically see in Flexo in a solid is the pattern of the analog cells to wall, making its way through to the print. And that gives you a lot of pinholes, a lot of voids, a loss of density. So by improving the ink laydown, by breaking up that pattern from the analogs, you basically get a much smoother, much better laydown. But that doesn't stop any of the unwanted ink spread or other features. So we introduced in 2016 with the NX Advantage, the first generation of multifunctional patterns. Here you have a different pattern in the center, or the main pattern, and a different smaller structure on the edge. We took the same structure from 2010 on the edge and had a larger pattern, so you get a better ink laydown, but you also have some control at the edge. You allow the air to escape, but you're trying to resist the ink coming out. So that multiple function is still trying to give you a nice, perfect laydown, whether it's white or process, but it's also giving you control of the ink flow and the airflow going through the system. So one thing that I often see as a misconception, a simple misconception with patterns, is when we build these surface textures, we're not trying to fill them. We don't want to get as much ink as possible. You build the structure to match the analog's volume. So in this case, the pattern is full. You end up getting air entrapment, you get mottled effects, you get a lesser looking solid. So you don't get the best result. That's partly because when the plate compresses, there's no space left. What we're really looking for is a structure like this, where we have it half full, 2/3 full, depending on the analogs, depending on the ink, but not full. But when you actually get the compression, because the plate comes in a printing action, you squash that down, so now it becomes effectively full and transfers a nice smooth laydown, gives you your optimum laydown. But if we don't have enough ink, then you end up with starvation. So it's a matter of finding a balance. You're finding a point where you have enough ink to fill the patterns to give you good transfer, but not too much to get air entrapment or not too little to have starvation. So it's a matter of optimization of the process. I'm going to show you the next slide, which shows the 4 generations of the NX solutions. So we have the 2008, 10, 16, and 21 solutions. There's SEM images of 50% dot. This is the same dot with the different generations of technology. There's a graphical representation underneath for how the patterns work and where they are. And then a graphical representation of what the final dot will look like, and also its size, to see the effect over time. So now moving to the next. So we start with 2008. Sorry. So in 2008, it was a flat top structure. It didn't have any surface texture at all. It's a typical Flexo plate, except it's flat. You can see the pixel for pixel imaging on the edges. You have the sharp reproduction from the digital file to the final print. That gave you the structure you see at the bottom, where you have a dot. It's larger than the original outline in the yellow outline. You have ink spread going off the dot, but also you have the pattern of the analogs coming through. So you have a lot of pinholes. You have a poor laydown. You have a low density out of that result. In 2010, we added the standard DigiCap, or the A00. That gave you the same pattern all over. It's still the smallest or finest of the patterns used in the industry. That allows you to work with low volumes, process analogs particularly, and it gives you a better laydown. It reduced the number of pinholes, but it didn't give you always the optimum result. If you have a little bit too much ink, you'll have more pinholes or air entrapment. You got good results, but you didn't get perfect. When we introduced the NX Advantage in 2016, you see here that it has the outer edge, the same pattern as we had before, and the inside has a different surface texture. This allows it to carry a different volume of ink, work with a different analogs range, and give you a better laydown. So you're less likely to have too much ink and more likely to have the right amount. So then you get a better laydown, you get less pinholes, you get a better result, but it didn't make such a huge difference to the ink spread. Any excess ink from the middle still gets pushed out. And then finally with Pureflexo, you end up with 3 layers in the same dot. You have the outer wall using the original structure. The inside is using the same structure as 2016. So that's optimized for your analogs. And then you have a micro channel inside the 2 of them, or in the middle, that allows the ink to flow. So you have a difference in volume with the micro channel to the actual pattern. That gives you a similar laydown to 2016, but with much less unwanted ink spread. The dot is smaller, much closer to the original. So how does that work? How do we really do this? So when we take the original dot and we look at it as before, as we compress it, we have the ink starts to get pushed out. As you compress the dot, any excess ink is being pushed towards the back. So you'll see the ink start to move. and then start to flow out. Then, because there's no structure to try and stop this, it flows off and you get the unwanted ink spread. If we take the Pureflexo example, then we have the structure with the microchannel, just the same. But now we make a change with the ink flow. So when this comes under compression, the ink again starts to flow out, any excess ink. It flows towards the back, but now instead of flowing off the structure, it flows around the microchannel. It allows the air and the ink to escape within the structure, and you end up with then much, much less ink that's pushed off. You can't stop all of the ink getting pushed off. It's much, much less. So it's much less significant. So this is evident by the numbers here. You see the results from a digital linear file, same digital reproduction on the plates, except on the left it's without Pureflexo. On the right it's with everything else is the same. It's the same plate side by side. And what you get as a result is you're reducing the unwanted ink spread. The numbers show you've gone from 86 to 76. That gives you a significant reduction because of the physical gain that you had. It's basically the ink has not gone off the dot in anywhere near as much. It's still not the results that you're looking for perfect color management. You're still looking for a 68 to 72. You still need color management. Color management is critical to giving you the results and predictability for the brands, and also ability to match a proof. But because it's much less variant, or much less change, you need to make much smaller levels of compensation. It's also less sensitive to the press operators, which gives you more stability. So the print you achieve is much more stable, much more predictable. When we look at this as an ink laydown, as we talked about before, if I look at a solid from 2010, the structure used in 2010, and the dot gain compensation that goes with that, Flexo has a pretty high dot gain characteristics. You can see that as we go through the toner range, this is an additional gain. So when we went to 2016 and the NX Advantage, you got a better laydown, you had less holes, you get a better density. So you can use the same amount of ink and higher density or less ink to achieve the same density. But you had a very similar compensation, dot gain compensation results. So your curves are very similar. There wasn't a significant difference because you're not stopping the ink spreading off the edges. Difference for Pureflexo is we have a very similar density, similar laydown, because it uses the same structures as 2016. The effect of that microchannel on the outside, though, by stopping the ink spreading off, gives you a much, much lower curve, much closer to a grackle or a faux type results, and much closer to the target we're looking for, giving you the results that Flexo has been looking for many, many years. When we look at this visually, we can look at, this is an image of a baby's eye. Without Pureflexo, you end up with bridging, you end up with the dots growing. It gets darker. With Pureflexo, you end up with a, yep, there we go. The eye is much clearer, much brighter, it's much more appealing. The only difference in these two is literally the microchannel. Everything else is very similar. So you end up with a much more visual, much more attractive on-shelf look at the final print. This is all about shelf appeal, smoother, lighter colors, greater detail, being able to reproduce colors and toner range that Flexo traditionally struggles. Think about pastels, think about soft colors that Flexo is normally challenged to do or is forced to use spot colors. One of the other areas we have benefits is bridging. You already saw some examples. If I have a digital file like this, the same on both sides. The left is without Pureflexo, the right is with. Then what you end up with is a result where on the left you can see this bridging, it's filling in, it's starting to go with it. On the right, all of the tone is still open. That's at 55%. Typically in Flexo, you're bridging at this point. So you're getting a much cleaner, much greater result through the toner range, much closer to the original. Now we're looking at latitude. One of the biggest issues in wide web flexible packaging is TV. TV is one of the defects that people often see. TV is those little voids you get at the trailing edge. They're resulting from an air bubble that bursts, and there's no time for the ink to come back in. That's why we talk about controlling air, controlling the airflow, getting the air to move. Because if you can make the air move, then you get away from this problem. Typically in Flexo, one of the things that we've done to address that is we use a harder tape. So instead of using a soft tape, which is great for highlights, we get too much TV, as you see on the right. So we're forced to use a harder tape, which causes other issues. So with Pureflexo, it allows us to use both softer and harder tapes by moving the air, by controlling the airflow. You're getting rid of a lot of the TV. You won't eliminate it completely. You can never do that. If you use the right ink analogs combination, you can still make it. But it's very unusual compared to what it was before. So it's really the first solution to technically solve this in a much more sophisticated and much better way. Now, if I look at how does that relate to the final print, I'm going to, this is the print that the baby's eye was taken from, the image of the eye. So you see here, the top image is without Pureflexo, with the 1, and the 2 is with Pureflexo below. The image below, you can see the mother's face is much clearer, the hair is much lighter, there's much more detail because you don't have the bridging between the features. The baby's face looks much brighter. So you can see that that's what visually what you'll see on the shelf is significant. But when we look at the plate that printed that side by side, you can see that there's a dark area on the typical Flexo. So you have a buildup of ink, you have a buildup where the hair is, so that's part of where you're getting this darker image, the more bridging. With Pureflexo, you don't have that same buildup, so you don't have to stop the press. That's going to give you the efficiency. So why is this working now, and what sort of things have happened in the past? Well, Flexo is very good at solving issues. The problem is we're often just moving them along. So it's not that we solve them, we just move them somewhere else and give us a different solution or a different problem down the road. If we think of the typical solutions for trail edge void or TV, that's that we'll put more pressure on it. Every Flexo operator knows a little pressure is good, so more must be better. So they'll squash it, they'll push more ink off. You use harder tapes. So the harder tapes, the example showed you, gives you the result of hiding or moving the TV away, but now you have more dot gain, there's more pressure on your highlights, you lose quality in that end, you have more bridging, you have more issues. Or we'll lower the viscosity. So all of that will allow the ink to flow more easily, and that will give you more unwanted ink spread, but won't really help you in the long run. These are very typical actions. Some defects like the TV, the voids, you solve one, but you create another. So we're just like that dog chasing our tail. We never make it to a really stable, really great position in the way that we would like to. So Pureflexo has allowed us to address a lot of that. It's allowed us to move forward by controlling the ink, by stopping the ink flowing off, giving us a better result. We have better ink laydown. We have more measured gain, lower measured gain values, cleaner print, less dot bridging, lighter tonal range. These are all things that make it more attractive. Then we come to more readable reverses. So the text is easier to read in the store. The image that's on the shelf looks more attractive. It's allowing us to use softer tapes, which will improve the image even more. From that latitude, you get better press operation, more efficiency, more productivity. So by addressing the issue, the fundamental issue, you're going to help the printer print more, print faster, print more consistently, and stop less. That really is the key to this. It's not about stopping the unwanted ink spread as much as the final impact of doing that. Once you've done it, the true benefits really come forward. And it's not just us that says this. It's this technology won an award at the FTA for Best to Show in Wide Web Flexible Packaging. This has allowed that printer to move to a new level. They also won the FTA Diamond Award. What's interesting for me is this is at 133 lines per inch. It was a typical gravure job. It was a gravure brand owner, that printed gravure all the time. This was their first entry into Flexo. They did not accept to have that image flexoized. Didn't want it simplified. Didn't want all of the things that we're used to doing to make it easier. They wanted it to look like Reviewer. They weren't accepting anything else, and that's why it won the awards. It doesn't need to be 175 line like Reviewer. The 133 in Flexo looks better. Reviewer needs that for the text. We don't need to do that for text. So we can print the equivalent or better print at a lower line screen. And Pureflexo, by controlling the unwanted ink spread, is critical to that. So overall, key takeaways for me is that we have to address the underlying root causes for the industry issues. We don't want to just mask them, move them on, hide them. It takes a long time to work out what is causing these, how to fix them, how to address them. And we've been doing this for a long time. It's built on the different levels of technology all the way along. Each step has been critical to improving the process, but also understanding it further and taking it to a new level. And Pureflexo, by allowing us to resist the unwanted ink spread, reduces the need to stop the press and clean plates. It improves the print-to-proof match and stability, critical for the brand owner's confidence. With COVID, the ability to do press approvals is significantly reduced or significantly more difficult. So the brand owner trusting the proof is really, really important to trust and grow the Flexo business. It reduces the impact of the operators. So whether it's run on the first shift or night shift, it really doesn't matter. The operator will have a much less significant impact. And overall, that will allow you to run much more through the factory, get your maximum uptime on your most expensive piece of equipment, your press, and allow you to operate it at the best ROI possible. So in summary, Pureflexo has given us a great movement forward. It provides wider operating window. It's built on those years of expertise. We've patented the technology. It's available with the NX system. It's built on the ability to do pixel for pixel reproduction from the original introduction all the way through. It can be done with all of the NX systems. It's designed specifically for the worst case scenario, which is wide web, solvent inks, and flexible packaging, and for process printing. So it really gives you that benefit with a lower volume, giving you better results, better reproduction, whether it's 4-color or 7-color ECG printing. You can really take it to a new level. You have the best gamut, the best results, the reproduction. So we're seeing this grow very quickly, and acceptance is becoming the default for a lot of customers.
Sorry, I don't know that.
And for the final piece, we've just completed a white paper. It's available if you would like to download it. You can see the link above. It's available today, and it's available, I believe, in 9 languages, or will be. So you should be able to see and read that at your leisure. Michal, over to you.
John, thank you so much for sharing that presentation with us. Really appreciate that. Some great insight there into a problem which so many printers will have. And so it's quite clear to see the benefits available now for those who do pursue the solutions which you've outlined today. So thank you very much for sharing those with us. Now, of course, there are plenty of questions which have come through. I'm going to skip the queue, though. I'm going to go ahead on some of my own first before I get to the audience questions. So first of all, Pureflexo was launched around a year ago. Could you give us an update about the market acceptance of this and about any commercial success?
Okay. So we've been growing it because it's used in the NX base. It's been growing with that throughout the base. What we are seeing is people will install it. They'll typically test for a few weeks or a few months, depending on the access to press. Press access has been difficult in the last year. And then it becomes the default solution. 3 to 4 months into use, it becomes the default. And people are just transferring all of the new jobs to this technology. That's a sign that the printers love it, it works, and the adoption will continue. So we're seeing that in all regions around the world. So it's been a very successful launch, and I think actually it's even gaining more momentum now as people have time to actually run and go through the testing.
Okay, and I think you covered this on your sign-off, What types of applications is Pureflexo designed for?
So Pureflexo is designed for the solvent-based inks with flexible packaging and predominantly process. So what we are seeing is more and more of our customers. Flexo is a very innovative industry. You give somebody a tool, they try it somewhere where it's not built for. We know that Pureflexo works in other applications. We've seen it with water-based on film. We've seen it with paper substrates. It works differently in those applications, so the guidance will be different in the future. But we see the dominant application for this is solvent-based process printing, but we see it being used in more and more places. One customer yesterday was using it on corrugated. So it's an industry that we will never stop people doing different things. That's part of the joy of this industry. We're an innovative group.
So no fixed rule,
No.
never anything. Okay. And does applying Pureflexo patterns create additional steps within the pre-press process?
No, it doesn't, because once you've decided to use the patterns, it's just a selection at the imager, or it's a tag in the pre-press that is applied automatically at the imager. It's the same speed. It doesn't slow the imager down. It doesn't do anything different to before. So whether you're using the technology from 2010 or 2016 or 2021, you're not going to see any difference in imager speed. It's just a selection option, and the imager does the rest.
Okay. Now a selection of questions from the audience now. Is Pureflexo printing only for Highline screen applications?
No, actually, the example I showed was at 133. Flexo is kind of into this. The higher line screen must be better, but actually, reality is that we don't need to print as high a line screen as Gravure. Gravure does it for the text, not for the images. When Flexo prints at 120, 133 lines per inch, sorry, I can't do the metric conversion in my head today. We end up with a much better result. You have the control of the gain, so you can make the dot grain much less, the control much better. So you don't need to do highline screen. It's really done for, and is actually probably even more effective at the lower line screen than the higher. So typical Flexo that everybody does today is perfect for this. The premium, it works at, but the typical is much better.
And I know towards the end of your presentation, you referenced a job which was taken from Gravure and now was printed Flexo and went on to win awards at the FTA. Do you foresee many more jobs being taken from Gravure onto Flexo using Pureflexo?
Yes, I do. We've actually just watched one customer move 600 jobs. So it's really a very significant trend. It's something that we're seeing more and more. Gravure's not going away fast. The infrastructure, everything else means it will continue for a long time. But the flexibility that Flexo has with brand owners, the ability to change designs instead of running one design all year. They'll do seasonal, they'll do promotional, sports related, and mix it in with the normal means that Flexo has a huge advantage in production, productivity, and speed to market. And the brand owners, when they start to make that change, really learn that. So once they get confidence that what you put in the digital file and on the proof is what they're going to get, we see more and more of that movement. So it's going to continue. The trend is definitely there. And Pureflexo is critical because it allows you to hold that stability that they're looking for.
How far can Pureflexo go to addressing some of plate longevity issues? Does that have effect at all?
It can help. It certainly helps because part of what you do to address other issues like TV is you use a harder tape. The harder tape causes the plates to wear faster. When you can back off the impression because you're not transferring too much ink or you're not having other issues, you can use the softer tapes. Then you end up with all of those things that you did before to address and hide things, make it worse. So all of the things you can now do in reverse to make it better will actually help plate life as well. So we haven't really had huge issues with plate life anyway, because the surface is always kind of lubricated. So you don't have a high friction unless you're putting a lot of pressure on. But this helps it even further. So we get even better plate life coming back from this than before.
Okay, and does Pureflexo work with different types of screenings? Would you need to use it with different screenings?
So one of the nice things is if you've applied screening, you have different patterns you apply. Because it's applied at the imager, if you have a suitable results, then it can apply to anything, whether it's coming out of an ESCO, a hybrid, a Prinergy workflow, we don't care. We're pre-press agnostic. So we just take whatever people give us as a 1-bit diff and it applies at that point. So it's sort of, it's not an issue. And it's something that allows people to be inventive and creative with the screening and still take the advantage of the technology at the end.
Okay. And comparing Pureflexo with other Miraclon technologies, what is the difference of a plate with Pureflexo compared to a Flexo NXH plate without it?
So all of the technologies that we've done before, the plate itself isn't that different. The technology applying it isn't that different. It's how it functions. So all of the previous generations haven't worked or haven't had a significant effect when the plate is under compression. When you're actually transferring ink to it or from the plate, they don't stop the ink flowing off. They won't stop all of that. Pureflexo really drives that change because of when we compress the plate, and every Flexo plate gets compressed. So it's critical to function, but that move forward allows us to give us the control and the understanding that, hey, what we were doing before was good, but it didn't work when we compressed. Now we have ability to control the ink flow when we're compressing. That's really a big step forward.
Can you see this this technology helping out with things such as decreasing ink consumption? Raw materials at the moment really scarce. There's a huge supply chain issues. That's an issue which a lot of printers will be worried about. Is this in any way going to help them with that?
I think it helps in several ways. It helps the greater use of process printing, because if you can make the print more predictable, you can make it more stable, whether it's 4-color or 7-color, then you can hit more colors. So you use less spot color inks because you don't need to do the spot anymore, because you can hit it with the process accurately within results. So you're not loading a deck of ink and then having to unload it and store the ink or throw the ink away. So you get away from the spot colors much more. You're going to drive to a much more fixed palette process printing. The other side is that because you're not spreading the ink around as much, you're not losing the ink around, you haven't got that gain, you're going to get 1%, 2% improvement in ink usage, ink loss. It's not going to be 10 or 20 that people get excited about. But if you're running all day, every day, and it's 1% better, that adds up over time. But really, the big difference is getting rid of the spot colors, moving to more process, and improving your press efficiency. Every time you have to wash a deck down, change it, you lose press time. So it's by sticking to process printing, change the plates, run again, next job, change the plates, run again. You're going to use the ink in a much more efficient way. So really, that's one of the key things. Also, drying for spot colors, you need more energy to dry. That's a big issue at the moment with the gas access. So you end up running the press more efficiently, using the least amount of ink possible, and getting the best possible result. Good question. I like that question.
Is there a preferred analog surface structure that works best with Pureflexo patterns? Or
so when we because of COVID, we had a delayed launch with Pureflexo, and so unusually high numbers of jobs were run before. So even before we launched publicly, we had over 20,000 jobs run, and that was on almost every plate surface texture you can use. So whether it's traditional hexagonal, it's an extended cell, it's a channel, it's an open channel, it's a partially open channel. We have results with all of those, and it functions with all of those. It gives you, if you're trying to print at very high speeds where people are trying to go, we see more of the extended cell working better. If you're using a lower line screen, then it doesn't really matter. It all depends on how you're trying to control the ink. But Pureflexo doesn't care. It works with everything.
Okay. When comparing Pureflexo setup costs for an 8-color Flexo job to an 8-color gravure job, is there any idea of what the cost saving to the customer in this conversion could be using the same colors?
So using the same colors usually means spot colors as well. We have seen numbers from customers. I'm not at large to share those. It is attractive. There's a lot of different grades of gravure cylinders. So that's one of the things. People always quote the lowest price and show you the highest quality roll. It's never quite fit. But what you actually have is probably if you want to run one job for a long time, the gravure is going to come out as probably more effective. The reality is that if you run Flexo in an efficient way, so you're running it as a process, you're not trying to print a gravure job, but you're printing against the proof, matching the proof, then the Flexo is going to come out cheaper and often significantly cheaper. We know with the brands that have just changed a huge number of jobs that not only have they seen an economic benefit, they see a benefit, and now that they can change designs, which they wouldn't have done with gravure. So they can have seasonal, they can have promotional, they can have much more engagement on the shelf to drive sales. So it's not as simple as what are the cylinder versus the plate cost, is what is the end sales for the brand owner. And Flexo wins out on that almost every time. On shelf, the whole idea on shelf, if you do gravure and Flexo, is you can't tell the difference. And if, as an industry, we put our loops away and we just pick it up like we're a consumer, then Flexo will always win out.
Perfect. I think that's a great way to finish it, actually, John. So I'm just going to say thank you very much for sharing your presentation with us, and everyone who joined us today. Thank you very much for giving us your time. And a big thank you to Miraclon, our sponsor today. If you did enjoy this session, you will be sent an email with a link to the recording of it. And if you're hungry for more great content, make sure you registered for Flexo Tech Magazine. Easily done with a quick Google for the latest news and in-depth features, online and in print, all dedicated to the Flexo industry. That's all from me and John. So thank you for watching and participating. And again, thanks to you, John.
Thank you
Goodbye.
very much.